Okay, now we want to develop a method for calculating surface area over a surface that's defined parametrically. So, in other words, generally like this. And we argue the same way as before when we use double integrals to develop a method for calculating surface area. We consider a tangent plane at a point. And what we do is we get two vectors that are on that tangent plane, and we calculate the area of the parallelogram formed by those vectors. So for example, let's take a vector in the u direction. And I will multiply that by a constant, just some scalar. I'll call it delta u sub I. And maybe that gives us this vector here. Here's a little picture of it. Then I can do the same thing with a vector in the v direction. I can multiply this partial by delta v sub I. So here we have two vectors, and they form a parallelogram on the tangent plane. Now remember, what we do is we argue that as we make that tangent plane, that parallelogram smaller and smaller and smaller, we get we get closer and closer to the actual surface area of that little piece of surface. And then we use the integral and sum all of those up. But to get the area of that parallelogram, remember what we do is we take a cross product. So I'm going to take the cross product of this thing, these two vectors. And then I'm going to take the magnitude of that. And that's going to give me the surface area. Okay, now, and of course, this leads to, we can easily write it this way. I can take out the u and the v. This is a property of cross products. And we've got delta u sub I, delta v sub I. Okay? Now, what that represents is the small bit of area on this tangent plane, that parallelogram. Very small piece. And what we want to do is we want to say, well, I want to let these delta u and delta v's be very, very small, infinitesimal, very small, and then I'll add up all of these little pieces. So I'll do this repeatedly across this surface. And when we do that, we know that what we've got then is we've got a double integral. And it's going to, this inside's going to be this way, and then we'll have, you know, the dA, where it's du, dv, I'll just call it dA. And we integrate this across whatever region has been specified. Now this right here is how we, this is the formula that we use to calculate the surface area for a parametrically defined surface.